So we'll start off by looking at this and we'll read through the questions. So it says, here's a pattern made from sticks. You've got 6, 11, 16. It says draw the fourth pattern in the sequence. So the next pattern in this sequence, I'm just going to draw it in there now. And the next pattern in this sequence is going to look like this. So the next pattern is going to look like, that's the first one. The second one, how it got bigger was, let's just draw that there. How this one got bigger was it got bigger by adding on this. So we added on 1, I'll do it in green actually, 1, 2, 3, and 4. The next one got bigger by adding on 1, 2, 3, and 4. So you can see there, this is the same as the third pattern. So the first pattern, the second pattern, the third pattern. So obviously the fourth pattern is going to be one bigger again. So I'm going to do one extra there, which is 1, 2, 3, and 4. Okay, so that is my first, or that's the third, or the fourth pattern, you could say. Okay, write down the sequence of numbers generated by the sticks in the first 6 patterns. Okay, so you should be able to note there how it's growing each time. It's growing each time by 1, 2, 3, 4. It's growing by 4 each time. Okay, so we started off with, oh sorry, see here my mistake. It's not actually going by 4, it's going by 5 because that's actually 2. I'll just have to split them. So you can see there that these are split. These are split. Okay, so the base one there is split. So it's growing each step by, it's growing by, let's see, it's growing by 1, 2, 3, 4, 5. So it's growing by 1, 2, 3, 4, 5. So it's going from 6 to 11 because it's grown by 5. There's 5 extra, 1, 2, 3, 4, and 5. It's going from 11 to 16 because it's going by 1, 2, 3, 4, 5. So we can see that it's growing each time by 5. So I'm just going to draw on the next stage. So write down the sequence of numbers generated by the sticks. So the sequence of numbers is going to be 1, 2, 3, 4, 5, 6. 6 plus 5 will give me 11. Plus 5 will give me 16. Plus 5 will give me 21. Plus 5 will give me 26. They wanted how many? The first 6 patterns. So 26 plus 5 will give me 31. And you can see there that's a linear sequence and it's grown each time by plus 5. Okay. The reason why it's a linear sequence is because it has the same common difference. Okay, so the difference between the terms is the same. I'm just doing that in green so that you'll know. Okay, so that's the first 6 terms. So show that the number of sticks in the nth term is given by this pattern, 5n plus 1. Okay, so in order to find the nth term, t of n, okay, so in order to find t of n, what we need to do is we need to look at the pattern. We need to work out what one comes first. So if we were to go back 1, we'd have take away 5, and 6 take away 5 leaves us with 1. So t of n will be equal to 5n, okay, because the common difference is 5, plus 1. Okay, and that's what they asked us to prove. So they said show that the number of 6 is given by t of n is equal to 5n plus 1, and we've got it there, 5n plus 1. 5n because that's the common difference, plus 1 because we're adding 1. Okay, how many sticks are required for the 20th pattern? So the number of sticks required for the 20th pattern, we'll just look at that now. So t of 20 is what they're looking for. So t of 20 is what we're looking for. So t of 20, so 5 times 20 plus 1. 5 times 20 is going to be 100 plus 1, which is 101. So if you wanted to make 20 patterns, you would need 101 sticks. Okay, so that's what that's telling us. So that's telling us in order to make 20 patterns, you would need 101 sticks. So if you were to make, so obviously if I was to make the first pattern, I'd need 6 sticks. If I was to make 11 patterns, or sorry, if I was to make 2 patterns to the second term, I'd need 11 sticks. But if I was going to make 20th, I'd need 101 sticks. So which of these patterns are 51 sticks required? So for which pattern is 51 sticks required, right? So you need to look at your T of n. So T of n is equal to 5n plus 1. If they want an outcome of 51, I want an outcome of 51, and I want to find out what pattern, so the number of the pattern. So if I was to use that, the n would be the unknown, and the solution would be 51. So I'm going to fill that in. So 51 is the outcome, and obviously n is still the unknown. So in this case, I need to solve that. And if I was going to solve that, what I would do is get all my n's to one side, get all my numbers to the other. And I'll do that now. So keep the 5n at this side, equals 51. If I bring that number across, it'll turn from a positive 1 to a negative 1. So that tells me that 50 is equal to 5n, so n will be equal to 10. So my answer there is 10. And what that means is that the 10th pattern, so the 10th pattern, if I was to draw the 10th pattern, so if I was able to draw out the 10th pattern, the 10th pattern would require 51 sticks. So I'd need 51 sticks to make the 10th pattern. So with question 5, we'll have a look at that there. So here is another pattern made of matchsticks. So you can see the pattern there. It says how many matchsticks will there be in the fourth pattern? So you can see there how it's growing each time, and each time it's growing by 1, 2, 3, 4, 5. And here it's grown by a further 5. So we know it's a linear pattern because it's grown by 5 each time. But in order to find out how many matches there is in the next pattern, we'll just put numbers to it, okay? So we'll start off there with part I, okay? So with part I. So in order to find out, we need to see, so the first term there has, we'll start off here and we'll say 1, 2, 3, 4, 5, and 6. So the first one there has 6. The next one has obviously your 6 plus 7, 8, 9, 10, and 11. So we have 11 there for that one. The next one is going to have 5 more. So it's going to have 11, 12, 13, 14, 15, 16. So it's going to be 16. So we can see there that this pattern is growing each time by plus 5. Okay, because we're adding 5 each time. So the fourth one, I would expect to have 16 plus 5, and 16 plus 5 gives us 21. Okay, so my answer there will be 21. Okay, part 2. So part 2 says, what is the term-to-term rule for the pattern? And the term-to-term rule is going to be add 5. And we know that that's obvious. Add 5. Okay. And you can see that because it's grown by 5 each time. How many matches or matchsticks will there be in the nth pattern? So in order to find out what the nth pattern is, we need to look at the pattern that we have, okay, which was 6, 11, 16, 21. And we need to find the term that comes before all of that. So we're going to go back a term. And if we go back a term, we'll be left with 1. So T of n, or the nth term, is going to be T of n is equal to 5n plus 1. Okay, we should always test it. So when we get the nth term, we should always test it to make sure you're correct. So let's just put 1 in there. If we put 1 in, we get 5 times 1, which is 5, plus 1, which gives us 6. So it works for 1. Does it work for 2? 5 times 2 will give us 10, plus 1 will give us 11. So that's working so far. Let's try it for 3. So if I put 3 in, 3 times 5 will give me 15. 15 plus 1 will give me 16. And I'll just try it for 4 as well, just to be sure. So 5 times 4 gives me 20, plus 1 gives me 21. So I can see that that works. So T of n is equal to 5n plus 1. Okay, the question is how many matches will there be in the n pattern, which we've done. So the next one there is which pattern will contain 66 matches, okay? So when you're looking at the nth term, okay, they want to know which pattern will contain 66 matches, okay? So the number of matches is going to be 66. So if they want to know which pattern will contain 66 matches, we need to look at this. N represents the term. So n represents the term. So here, when we put 1 in for n, that's telling us that the first term will have 6 matches. If we put 2 in, it's telling us that the second term will have 11. Okay, so the number of matches is the outcome. Okay, so they want to know which term will have 66 matches. So if it has 66 matches, the outcome will be equal to 66. So the outcome will be equal to 66. And we want to find out which term it is. So the unknown is going to be the term. So we're trying to work out what that term is. So in order to work that out, all we do is basic algebra, bring the 1 over to the other side, and it turns into a negative 1. So we'll have 66 minus 1 equals 0, or equals 5n. So to find out what 1n is equal to, we can say 65 is equal to 5n. So to find out what 1n is equal to, we divide both sides by 5. And 65 divided by 5 gives us 13. So n will be equal to 13. So the 13th term will have 66 matches. That's what we worked out there. Okay. So which pattern will contain 66 matches? And it's 13th pattern that will contain 66 matches. Will any pattern use exactly 88 matches? So the last part there is question 5. And they want to know, will any term contain exactly 88 matches? Okay, so the outcome, we're going to check to see if the outcome will give us 88. So if this is going to be correct, we'll say 88 is equal to 5n plus 1. Okay, so 8n will be equal to 5n plus 1. I'm going to solve that to find out what pattern. So I'm, sorry, just to make sure everyone's okay at that. The outcome, they want to know, is there any pattern that will contain 88 matches? So what I'm going to do is I'm going to put in 88 as my outcome and see what value it gives me. So it'll tell me what term it is. If I get a whole number, then that will be the number for the pattern. Whereas if I get a decimal, say I got, for instance, say I got 15.4. That means the 15th and a bit pattern. But there's no such thing as a bit of a pattern, right? So we're just going to work that out. So I'll bring the 1 over, and then I'll be left with 88 minus 1 is equal to 5n. So 87 is equal to 5n. So 87 divided by 5 gives us an answer of 17.4. So n will be equal to 17.4. Now, that's like I was saying. So if I wanted to use 88 matches, I could make 17 patterns, but I could make 17 and a bit patterns. I wouldn't quite make 18 because I'm short of matches. I wouldn't have enough matches to make the 18 pattern, but I would be able to make the 17th pattern, but I would not be able to make the 18th. So the answer for that is, will any pattern use exactly? The answer is no. Okay.